We are going to continue looking today at the different tissues in the body. Again, just to review from Monday, we have 4 types of tissue. Epithelial tissue helps with coverings. Connective tissue helps with support, and that's going to be what we focus on today. And then tomorrow we're going to look at nervous and muscle tissue. Nervous helps with control, and muscle helps with movement. So again, today we are going to focus on connective tissue. Connective tissue, like its name suggests, is going to function to connect body parts. It can be found pretty much everywhere in the body, so it's the most abundant and widely distributed type of tissue. And connective tissues can perform many different functions, including protection, support, and then binding or holding together other body tissues. Some characteristics of connective tissue are going to be variations in blood supply. Most connective tissue has a good blood supply, but there are exceptions to that. Tendons and ligaments both have poor blood supply, and cartilage has no blood supply at all. So if you were to injure yourself and you injure a tendon or a ligament or cartilage, they are very, very slow to heal because of that poor or lack of blood supply. Another characteristic of connective tissue is something called the extracellular matrix. There's going to be many different kinds of cells as part of connective tissue, plus different amounts of extracellular matrix, which is extra means outside of this, and then cellular means cells. So it's a substance found outside of these cells. Okay, we're going to talk specifically about that for a second. So that extracellular matrix is really what makes connective tissue so different from the other 4 kinds of tissue. It's produced by the connective tissue cells themselves and then secreted to the outside of those cells. And there's 2 main elements. So there's a structureless ground substance. Usually it's going to be water plus some proteins that help hold other parts together, other cells together. So it acts kind of like a glue. And then there's fibers within that. So that can be collagen fibers, elastic fibers, reticular fibers, depends on the kind of connective tissue. And it's able to form a soft packing tissue around other organs to help them either like stand up to stretching forces or help to bear weight. Our first type of connective tissue is bone. Sometimes it's referred to as osseous tissue. And the kind of cell that makes up bone tissue is called an osteocyte. So an osteocyte is a bone cell. And they sit in cavities called lacunae that are surrounded by layers of hard matrix. And that matrix is going to have calcium salt in it, as well as a lot of collagen fibers. And there is kind of a rock-like hardness to bone tissue, which makes it really good at protecting and supporting other organs. So down here you can see a diagram of bone tissue as well as what it would look like under a microscope. If we were in class, we would be able to look at different kinds of tissue under the microscopes, but we will, as part of this unit, be doing using a virtual microscope this year. So you'll still be able to see these things and what they would look like on our slides, but just unfortunately without the actual microscope. Next we have cartilage. So this is not as hard as bone, and it's also more flexible than bone. Cartilage cells are called chondrocytes, and we find these cartilage, that tissue, a few places in the body, and we'll talk about that. So there's hyaline cartilage. Probably if you think of the cartilage in your body, it's hyaline cartilage that you're going to be thinking of. So it's going to be rubbery inside, and it's because it has a lot of collagen in it. It will support your larynx or your voice box. It allows your ribs to attach to your sternum, so you can see that highlighted in purple up here. And then where your joints form, where your bones connect, that cartilage would also be hyaline cartilage. And then during development, the skeleton of a fetus is made of hyaline cartilage that's going to be slowly replaced by bone before birth, except at the growth plates. So that hyaline cartilage remains at your growth plates, and then when you stop growing, that hyaline cartilage is converted into bone tissue. Fibrocartilage is a second type of cartilage, and it's going to be very compressible, We have this in between our vertebrae called intervertebral discs. That help to cushion our vertebrae so they don't kind of crash into each other as you walk and move. And then we have elastic cartilage. So this would be like the cartilage in your ear, the cartilage in the epiglottis that covers up your trachea when you're swallowing something. So again, we have those three types of cartilage. Our next type of connective tissue is called dense connective tissue. Another name for it is dense fibrous tissue, and it has collagen fibers as the main element in its matrix, and it's going to be able, because of that, to form very strong structures that are similar to a rope. So this is going to be the kind of tissue we would have in our tendons, which attach our muscles to our bones, our skeletal muscles, I should say, to our bones, and our ligaments to attach bone to bone at our joints. It also forms the dermis of your skin, where this kind of tissue would be arranged in sheets. So our skin has two main layers. We have the epidermis, which is the outer layer, and the dermis, which is below that, just deep to the epidermis. So dense connective tissue or dense fibrous tissue would make up the dermis of the skin as well. So we have dense connective tissue. There's also loose connective tissue. This is going to be softer, I guess, like you would imagine based on its name. And it's going to be because it has more cells and less fibers than other types of connective tissue. All of the other kinds, actually, except for your blood. This includes areolar tissue, adipose tissue, and reticular connective tissue. So we'll go through and talk about each of those. For areolar tissue, this is going to be the most widely distributed connective tissue in our body. It's soft and pliable, and because of that, it's going to help protect organs that it wraps around, because it's going to kind of act like a glue to hold your organs in their correct spot and hold them to each other to help keep them in that spot. It also allows there to be a reservoir of water and salts for tissues that surround it. The wastes secreted by these cells are going to be released into that tissue fluid. So when there is an imbalance, like if you have inflammation or swelling, that is from the areolar tissue soaking up that extra fluid, similar to how a sponge would soak up water. And that area will swell and become puffy. That condition is called edema. Sometimes doctors will prescribe a diuretic medication, such as something like Lasix, or sometimes people call them water pills, but that helps your body flush out that extra fluid so that your tissues go back and they don't retain that and stay puffy like that. Next, we have adipose tissue. Adipose tissue is just fat tissue. It's going to be below the skin to help insulate the body and protect you as you bump into things potentially, as well as protecting you from both extreme hot and cold temperatures. If it wraps an organ, such as your kidneys, it's going to help to protect that. So it's going to kind of cushion them. It also cushions your eyeballs in your sockets, the eye sockets. If, I guess most of you probably, if you had Anatomy 1 last year, you didn't get to dissect the eyeball. But if you had it 2 years ago, then you would have been able to dissect the eye, and you would hopefully remember that the eye was surrounded by a lot of fat or adipose tissue. So that's there to help cushion your eyeballs in your eye sockets. And it's also going to be kind of available fuel that's stored for later use, typically in the hips and the breasts, but it can be stored elsewhere also if a person has an excess amount of fat tissue in their body. Next, we have reticular connective tissue. Reticular connective tissue is going to have kind of an internal network of reticular fibers that this tissue is going to be limited because of that to certain sites. We have this in our lymphoid organs that help support lots of free blood cells, mainly your white blood cells or your lymphocytes in your lymph nodes, your spleen, and bone marrow. So over here you can see the spleen, and you can see it's labeled here, some blood cells, those would be red blood cells, kind of suspended within the rest of that tissue. And then finally we have our last kind of connective tissue, which would be blood. This is also called vascular tissue. The reason why it is considered a connective tissue, it is the only fluid tissue in our body. I should point that out as well. The reason why it's considered connective tissue is really just because your blood cells, so those red blood cells, white blood cells, and platelets, are surrounded by a non-living matrix, which is kind of the defining characteristic of connective tissue. But in the case of blood, we call that plasma. The fibers of blood are going to only really be present when there's blood clotting, so they'll kind of form as your blood needs to clot. So now we have talked about epithelial and connective tissues, and tomorrow we will focus on nervous and muscular tissues.